Solving a cubic equation. From a general equation to a simplified one. In general, the cubic equation is defined in the form a multiply by x cubed plus b multiply x squared plus cx plus d equals 0, where a is not equals to 0. Let us assume that the numbers a, b, c, d are complex. By making the substitution y equals x plus b divided by 3a, the equation will be simplified to the following form: y cubed plus py plus q equals 0, where p and q can be calculated by these formulas. Solution of simplified equation. We will look for the solution of the simplified equation as the sum of two components, y equals u plus v. Then y cubed equals to u cubed plus v cubed plus 3uv multiplied by u plus v. Hence y cubed plus py plus q equals to u cubed plus v cubed plus 3uv plus p multiplied by u plus v plus q equals to 0. If both conditions are satisfied, then y equals u plus v will be the solution of our equation. These two conditions are y cubed plus v cubed equals to minus q and yv equals to minus p divided by 3. Suppose that one of the solution, u of v, is 0. It follows from the second equation of the system that this is possible only when p equals to 0. Then our equations have the form y cubed plus q equals to 0. Its solutions will be y equals to cube root from minus q. There will be three distinct roots in the complex numbers if q not equals to 0, and three congruent 0 roots when q equals to 0. Now consider the case when p is not 0. In this case, there are no zero solutions of our system. So we can express v from the second equation and substitute it into the first. We get the equation u cubed minus p cubed divided by 27u cubed plus q equals to 0. Doing variable substitution t equals to u cubed, we get the quadratic equations from t squared plus qt minus p cubed divided by 27 equals to 0. Solving the quadratic equation, we obtain the find u, which is equals cube root from t. U equals to cube root from minus q divided by 2 plus minus from square root q squared divided by 4 plus p cubed divided by 27. Since p equals to cube root from minus q minus u cube, we get y equals to u plus v equals this sum of two cubic roots. In the second root, we change plus minus to minus plus. If we take one of the values of the root of square root from q squared divided by 4 plus p cubed divided by 27 in the formula for u, Then for v it must be taken with a different side to satisfy the condition u cube plus v cube equals to minus q. Changing the sign causes permutation of companions, so any value can be taken as the root of our square root, and the formula becomes as follows: y equals to cube root from minus q divided by 2 plus our square root plus cube root from minus q divided by 2 minus square root. Since u multiplied by v equals to minus p divided by 3, the second summand v equals minus p divided by 3 is uniquely defined. And the general algorithm. We simplify the general equation to the reduced form: y cubed plus py plus q equals to 0, where p and q can be calculated using the formulas. If p equals 0, then the solution of the equations are y equals to cube root from minus q. And if p is not equals to 0, then take any value of the complex root, d equals to square root from q squared divided by 4 plus p cubed divided by 27, then calculate roots u equals to cubic root from minus q divided by 2 plus d. Since p is not equals to 0, then there will always be 3 complex roots. The roots will be y equals to u minus p divided by 3u. And from our roots of simplified equation, we find the root of the original equation using formula x equals to y minus b divided by 3a. Extras. Let us study the function f from y, which is equals y cubed plus py plus q, where p and q are real numbers. To do this, we find its derivative. F prime equals to 3y squared plus p. If p equals 0, there will be 3 coincident zero roots when q equals to 0. And if q is not equals to 0, there will be 1 real root. If p greater than 0, then f prime also greater than 0. And so there will be 1 real root. And if p is less than 0, then there will be 2 extreme points: y equals plus minus square root from minus p divided by 3. Let us find the values of the function at these points. It is equals to 2 multiplied by plus minus square root from minus p cubed divided by 27 plus q divided by 2. Let's find the product of function values in the extreme points. It's equals to 4 multiplied by q squared divided by 4 plus p cubed divided by 27, and which is equals 4 multiplied by d, when d is the expression in the brackets. On the interval minus square root from minus p divided by 3 and square root from minus p divided by 3, the derivative is less than 0. So the function f is decreasing there. So if f from y1 and f from y2 have the same signs, that is, f from y1 multiplied by f from y2 is greater than 0, the equation will have only one real root. If f from y1 and f from y2 have different signs, that is, product is less than 0, then the equation have three real roots. Let us write out all cases in the table. f1 equals to f2 equals to 0, then we have three coincident real roots. D equals to 0. If only one of the f is equals to 0 and the other is not equals to 0, then we have two coincident real roots. D equals to 0. If product of value of the function in two extreme points is greater than 0, then we have one real root, and d greater than 0. And if the product is less than 0, then we have three different real roots, and d less than 0. This table fits if p less than 0. Above we have considered the case when p is greater than 0. The table also fits for it, so the table works for all p. Thus we get, if d equals to 0 and p and q equals to 0, then we have three coincident zero roots. And if d equals to 0 and one of p or q is not equals to 0, then we have three real roots, two of which if coincide. If d greater than 0, then we have one real and two complex roots. And if d less than 0, we have three different real roots. On my website you can find a page on which you can solve equations of the power 2, 3, 4 online. And go to Other and find the solving equations of degree 2, 3, 4. Here you can enter the coefficients of every equation, and you can use the complex or real numbers. And the program automatically shows you polynomial and find all of the roots. And you also can input the value of the roots, and the program shows the same, the polynomial and the roots. You can use quadratic, cubic or quadric equations.